Today we're talking about classifying real numbers. Our learning target for today is I can classify rational numbers. So what does classifying mean? I want you to think about these 9 animals and whether or not they live in the ocean or they live on land. Go ahead and pause this video and determine where they would go. You can draw a Venn diagram if you would like. We know that a shark lives in the ocean. Just like we know a fox lives on land. But what about animals that live in both places? Like the crab, where would we place that? We would place it right in the middle of both circles because the crab can live both in the ocean and on land. Now we'll check our answers and see if you got the same things. So we have the shark, the whale, and the starfish all live in the ocean. The bear, the fox, and the raccoon all live on land. The turtle, the seal, and the crab live both in the ocean and on land. So we place them in the middle of both circles. Just like the traditional Venn diagram, there are also other Venn diagrams that you will see as well. Here are 2 examples. Now we're going to focus on where we belong. So there's 3 different circles: born in Texas, born in the USA, born on Earth. For example, I was born in Texas. So if I was born in Texas, that means I'm also born in the USA. And if I'm born in the USA, I was also born on Earth. So I would be a part of all 3 circles in this Venn diagram. So I would shade in the middle of all 3 circles. Now let's say I was born in Florida. So that means I was not born in Texas, but I was still born in the USA, and I am still born on Earth. So that would mean I would be a part of both the born in the USA and born on Earth circle. In the Venn diagram example on the right, using my first example, I was born in Texas. That means I was also born in the USA, and I was also born on Earth. So I'm going to place my shading where I belong first. So I am going to shade in the born in Texas circle blue. Now notice how this circle is inside of the other 2 circles. That means I'm a part of all 3 circles. Using my second example, if I was born in Florida, I was not born in Texas, so I can't shade in that circle, but I was still born in the USA, and I am still born on Earth. So I would shade in where I belong first, which is born in the USA. So I would shade in this circle red. So notice how the born in the USA circle is not a part of the born in Texas circle. It is not inside of it, but it is inside of the born on Earth circle, so that I'm still a part of the born in the USA and born on Earth circles. This is the Venn diagram you will see most often when you are classifying rational numbers. So let's review the classifications. First, we have natural numbers. Natural numbers started because they appear on your hand. We can call these our counting numbers because we count on our fingers 1, 2, 3, 4, 5, and so on. Some examples of natural numbers are 5, 10, 50, 17, 20. So a natural number is any positive whole number. Next we have whole numbers. Whole numbers are all the natural numbers and 0. So the only number we're adding in to the whole number category is 0. So it's all of our natural numbers from before. So 5, 10, 15, 17, any positive whole number, and then we just add. So we add 0 to that. Next we have integers. Integers are all of the natural and whole numbers, but now negative whole numbers. So any whole number that is negative is an integer. So that could look like -10, -2, -48, -50. All of these numbers are examples of integers. Last, we have irrational numbers. Rational numbers are all of the numbers that we've talked about before. So positive whole numbers like 5, 10, 15, 17, 20. Whole numbers where we add 0. All of our negative whole numbers are integers, -48, -50, -10, -2 are examples of integers, but now we're going to add any decimals and fractions. So there's a couple of different types of decimals. One type is repeating decimals. So an example of this is 0.333, and it repeats on forever, but there is a pattern. We know that it will always be 3. And then there are terminating decimals, where the decimal ends. And an example of this is 0.375. So any number that is a decimal or a fraction is a rational number. So that could look like 1/4, 3/7, 2 5/8, or decimals could look like 0 2/10, 2 5/10, and so on. All of the numbers you see on the right-hand side of the screen are all examples of rational numbers. Now let's talk about irrational numbers. Irrational numbers are the opposite of rational numbers in that they are not rational. I have some examples written down of numbers that are not rational. One example is pi. We've all heard of pi. Pi has a decimal that goes on forever and ever, and it does not have a repeating pattern. It does not terminate, and it is not repeating. So it is not rational, making it an irrational number. Another example is written right below pi of a decimal that is both not repeating meaning there's no pattern, and it's not terminating, meaning it never ends. If a number is irrational, it is not a rational number, which means it also is not an integer, it is also not a whole number, and it is also not a natural number. Irrational numbers are in their own classification group. Now it's time for some notes and guided practice. You have a blank copy of the notes located in Schoology in today's math lesson to follow along. First, let's look at some definitions. The definition of a natural number is all positive, non-decimal numbers. These are our counting numbers. The definition of a whole number is all positive, non-decimal numbers and 0. I have written some examples of both natural numbers and whole numbers. Notice how when we add whole numbers, it's all of the same natural numbers. The only thing is we're adding the number 0. Next is the definition of an integer. An integer is all positive and negative non-decimal numbers and 0. So now we're adding in all of our negative whole numbers. I've written some examples of integers. Notice how each time we're adding on. So it's all the same numbers from before, but now we're adding in negative whole numbers. So that could look like -2, -9, -18. Last, we have rational numbers. The definition of a rational number is all positive and negative non-decimal numbers, 0, and all fractions, and terminating or repeating decimals. So now we're adding in all the same number examples from before, but we get to add in decimals and fractions. I've written some examples of decimals and fractions that are rational numbers. So what do you notice when looking at the definitions and examples that we just talked about? Notice how each classification builds or adds on to the previous classifications. No numbers are ever being taken away, we're only adding on. Now in our notes, it asks us to label this Venn diagram with the terms from above. Instead of writing out the entire word, I use the first letter of each classification. So I put N for natural inside the smallest circle, W for whole inside the next circle, I for integer, and then R for rational. Then it asks us to place each number below in the Venn diagram where it belongs. We need to place these numbers where they belong first. So number 1 is 14 1/10. I notice that this is a decimal number. So the only classification it could be is rational. So I'm going to write 14 and 1/10 in the rational circle. The second number is 7 and 1/5. This number is a fraction. So again, it can only be a rational number because rational numbers are decimals and fractions. So I'm going to write it inside of the rational circle. The third number is -8. This is a negative whole number, so it is an integer. I'm going to write it inside of the integer circle. Remember back to our example at the beginning of the notes. If it is an integer, it is a circle inside of the rational circle. So -8 is both an integer and a rational number. The fourth number is 101. 101 is a positive whole number. It is a counting number. We could count it on our hand. So it is a natural number. I'm going to place that in the natural number circle. So 101 is a natural number, a whole number, an integer, and a rational number. It is inside of all of the circles. The last number is 25ths. And this one can be tricky at first because it is a fraction. However, the numerator is larger than the denominator. So we have to divide and figure out how to make this a proper fraction. So remember, we are going to put the top dog in the house. So I'll set up my division problem. And we need to figure out how many times 5 can go into 20. Well, 5 times 4 is 20. So 25ths is actually 4 wholes. So 25ths is equal to 4. Therefore, although it looks like a fraction at first, we know that it is 4 wholes, and so 25ths is a positive whole number. It's a counting number. Therefore, it is a natural number. It is also a whole number, an integer, and a rational number. It is inside of all of the circles. The last section of the guided practice asks us to classify each of the following numbers as natural, whole, integers, or rational numbers. Again, I'm going to use the abbreviations instead of writing out the entire word. So the first number is 82. This is a positive whole number. It is a counting number, so it is a natural number, which means that it's also a whole number, an integer, and a rational number. The second number is -71 and 3/10. This is a decimal number. Therefore, it can only be a rational number. The third number is -6. This is a negative whole number, so it is first an integer, but it is also a rational number. The fourth number is 0. We know 0 is a whole number, which means that it is also an integer and a rational number. The last number is 3. This is a positive whole number. It is a counting number, which means that it is natural. If it's a natural number, it is also all of the other classifications. It is a whole number, an integer, and a rational number. Now it's your turn to complete some independent practice on your own. You will submit this inside of Schoology. First, before you complete your independent practice, watch a music video about classification of rational numbers.